Okay. Okay. Hello, everyone. So let's start with the next question. Next question is construct a binary tree from preorder and inorder traversal. So given two integer arrays, one is the preorder traversal, another one is inorder, and construct and return the binary tree. Okay. Acha. So we are given the preorder traversal. 3, 9, 20, 15, 7, and the inorder traversal. This is pre, this is in order is 9, 3, 15, 20, and 7. Okay, so we have to create a binary tree out of this. So in order is left subtree, then the node, then right subtree. Pre-order is node, then the left subtree, then the right subtree. Okay. So the first node of pre-order is going to be our root node for sure, right? And since in order is left node and right, so if we know the position of this one, all the nodes on the left side will be in the left subtree, all the nodes on the right side will be in the right subtree. 15, 20, 7, these will be in the right subtree. Okay. Then if we go to the left one, so 9, left subtree ka root will be 9. All the nodes to the right, to the left will be the left subtree. There is no node, it will be null. And all the nodes to the right before this node will be the right subtree. So there is nothing, so it will be null. Then comes 20. So 20 will be the root node on left side. Then 20 के left में until 3 all the nodes will be in the left subtree. All the nodes after 20 will be in the right subtree. Then for 15 the same thing will happen. It will be null, it will be null, it will be null, be null. Okay. Okay. So basically, first thing is that we are creating the nodes from the pre-order traversal. Right? एक करके we'll create these nodes. And we need to know the position of these nodes in the in-order traversal to identify the left subtree and the right subtree. Okay. And okay, so we'll make a, say, a lookup kind of thing. Let's say a hash map. So we'll make a lookup or a map for these nodes for the index of 3, 9, 20, 15, and 7 in order traversal. 3 का index is 1, 9 का index is 0, 20 का index is 0, 1, 2, 3, 15 का is 2 और इसका 4. Okay, so now we know exactly where the nodes are. Okay, let's call it lookup. अब Now we'll have a I here. We'll keep incrementing I. We'll find the index here of this node, of the ith node, and we need to have a left and right bound because we need to find out the index of the ith node here, and all the nodes to the left of that node will be the left subtree, all the nodes to the right of that node will be the right subtree. But say for 20, all the nodes to the left of 20, but after 2, after this node, after 3 node, है ना? So all the nodes before 20 and after 3 are the left subtree of 20, and all the nodes after 7 are the right subtree of 20. So we need to keep 2 more pointers, L and R, left and right, say, which will be 0 and n minus 1 in the beginning. Then every time we need to update. Suppose for 3, we found 3 here. So nodes from 0 or left, from the left to I minus 1 will be our left subtree. And from I plus 1 to R will be the right subtree. Okay. And when we call for right subtree, we'll update our left pointer by, we'll keep it to I plus 1, जो current ith node का index plus 1. Okay, let's call it, इसको x बोल लेते हैं. Now इस node का index is I here. Okay, so this node का index plus 1, so L will be here. And if we are calling to the right sub for the left subtree, we'll make right here, meaning right will be I minus 1. And will it work? Will it work? So where should we break it? So see, for 9, what will happen? All the nodes to the right, meaning 0, L is 0, right? And uh, R will also be, L is already 0. And when you are calling for the left subtree from here, we'll make R 0. So if L and R are becoming equal, तब there is only one node, है ना? So if L goes above R, we return null. This case and this case, right? Otherwise, we'll create a new node, assign it to, and इसका left subtree will call for the left subtree, updating our left and right pointers, and similarly, right subtree updating our left and right pointers and updating our index, this index x. Okay, I think it should work. Let's try it. So first of all, it got too messy actually, but if you think about it yourself, I think you'll get a better understanding. First of all, we want to increment x every time. So let's take it as a global variable, or let's take it I. Let's take it as a global variable, keep it 0 initially. And also we need a map of integer my teacher for the lookup. Okay. First of all, we need to create this lookup for pre-order in-order traversal. So less than, it's a very long name. I'll make it pre and in dot length is plus then lookup dot will put the element in dot in ith and I. So now we know index of all the elements in in-order traversal of the all the nodes in the in-order traversal. See, this map will work. What if there are duplicate node values? Is there Acha, no. All the consist of unique values. So this map is okay. Because if there are duplicate nodes, then this map will have a duplicate key and it will be overridden. So in that case needs to be considered. But it's given in the question that there are only duplicate values, the only unique values. So that's okay. Okay. So now we have the map. Now we'll write the main function. Actually, it will return us the root node and let's call it fun. It will take in order and both the arrays and it will take a left and a right pointer. Okay, now what had we decided? If L goes above R, we instantly return none because there is nothing uh, that node doesn't exist because L and R are defining the left and right subtrees. So if L is going beyond R, it means that there is no left and right subtree, and also the node itself is not there. That's why. So if L is equal to R, it means that the node doesn't have left and right subtree. Okay. Okay. So if L is greater than R, we return null. Otherwise, we create new node, call it root. Mhm. In into in pre-order ka I. Okay. Now we want the index of this pre-order ka node in order. So we have lookup already. So let's take in IND and lookup dot will get lookup dot get pre-order. Sorry, pre-order ka and let's increment I for the next iteration. Now root dot left will be the same pre-order in order, but we'll update the left and right pointers. So from where will the left subtree start? From this index, this 3 is index -1. So IND, sorry, left will be the same and right will be IND -1. Right? And the right subtree will be pre in left will be IND +1 and right will be the same. Right? We'll return then the root. Here we will just instead of we'll return the function and pass pre in left 0 initially and right will be Last one. Okay. Will this work? Will this work? Let's do a try run. So we are building the tree. We look up बना लिया. Start. We get three का index. And then we created a new node from pre-order का ith index. We got the index of this one is this. We incremented I will come here. Now root का left will be. We'll call the same thing for left is already 0 and id -1 which will be 0. Okay, then create another node. We increment I comes to 20. 9 का node बन गया. We get the index of 9. It will be 0. Now we again call for left. Now R will go to -1. So it will return null. Left will be null. Right will be null because R is 0 and L will be 1. The right will be null. And then we return 9. So this node will be returned to this. And root ka left will become 9. Again for right, this same thing will be called. Yes, it should work. So let's run it. So okay, both the cases ran. Yep, this works. Okay. So this is a good question. There are more questions like this. I think maybe I'll do those also. I should do creating. So as we know that we can create a binary tree if we are given the in order and any of the other two, pre-order or post-order, then we can create the binary tree. So there will be one more question where we'll be given post-order traversal and in-order traversal. And we have to create the binary tree. So maybe we'll do that in the next video. Okay, thank you. Bye.